In this lecture, we're going to be learning about some facilities in the C++ standard library that can help us manipulate characters. And here are a few things you might want to do with those facilities. For example, you might want to know if a character is alphanumeric or if it's a number or a character. You might want to know if it is alphabetic. You might want to know if it's a blank character. You might want to know if it's a lowercase or uppercase character, depending on what you want to do in your application, of course. There are facilities to check if characters are digits. There are even those that help us, transform characters, make them lowercase or uppercase. And we're going to see these examples here. All of these are documented at cppreference.com, so you can go there and find the documentation. Here is the same link opened in my browser. You see that they live in the CC type library, so you need this included if you want to use them. And you see that there is quite a bunch of them. We are going to cover just a section of them, and I will leave you to use the documentation if you need to use any more of these guys. Our first example here is going to help us check if a character is alphanumeric. And the function we're going to use from the C++ standard library is std_is_alnum. And you just pass it a parameter of a character, and it's going to tell you if a character is either alphanumeric or if it's not. If it is alphanumeric, you're going to get a value that is different from 0, which can be treated like a true. If it's not, you're going to get a value that you can treat like a 0. And how do I know this? Well, we can check the documentation. So if I come back to our link here, and there is a function here, is_alnum, I can open it in another tab, and it is going to tell me what this function does. Checks if the given character that you pass as a parameter here is an alphanumeric character as classified by the current C locale. So it's going to tell us if the character is alphanumeric or not. You give it a character, and what you get from it is the return value here. It's going to return a non-zero value if the character is alphanumeric. So this non-zero value, which is an integer because that's what we get out of this function, is going to be treated like a true. And if this character here is not alphanumeric, we're going to get 0 that we can treat like a false. This is really cool. And if you go down here, you're going to find a few examples. I don't want you to worry about this C locale thing. It is a setting that allows you to say more about the meaning of the characters that you are storing in memory. But for now, we're just going to be happy with the defaults and use this function as is. It is going to work enough well. Okay, here is our function again. So here C is alphanumeric. We expect to get a value different from 0 because C is alphanumeric. And the second example here is not alphanumeric, so we expect to get a value that is equal to 0. And we can use the return of this function in a test. For example, we can say a character, we put in a star here, it is called input char, and we say if is alnum, and we pass this character, we're going to print out this character is alphanumeric. If it's not, we're going to print is not alphanumeric. You can do that, and you can do all kinds of crazy tests in your C++ applications. Here is another example that we can use to know if the character is alphabetic. So it's going to return a value different from 0 if the character is an alphabet character A through Z. That's going to return something different from 0. And if we pass something that is not, for example, this second line here or the 7 at the third line here, we're going to get a value equal to 0 because that's not alphabetic. We have another facility to help check if a character is a blank character. And we see an example of that here. We have a character array called message. We have a couple of blanks inside, and we can hunt for them using the isBlank facility from the C++ standard library. Here we have a variable that is going to keep track of how many blank characters are in here. It is initialized to 0, and we're going to loop around. Okay, and we're going to loop by the amount equal to the size of the message array here. We can use std size again because this is a row array, it is a static array, and we can use std size. It is going to give us how many characters we have in this array. You already know this. And if we get inside, we are going to try and check and see if the current character is a blank. If it is, we're going to print that out. and we're going to increment our blank count. By the time this loop is done, we will have printed out a lot of blank characters if we happen to have them in our message. And at the end, we're going to say in total, we found however many blank characters. This is what we're going to see if we run this program. And hopefully you can see how useful this can be in text processing applications if that happens to be what you are working on. We're going to run this example in Visual Studio Code in a minute. Here is another example that we can use to check if a character is uppercase or lowercase. We have an array of characters here. Inside we have some text, and we have a few variables to keep track of how many characters are lowercase or uppercase. We're going to set up a loop, which is going to be a range-based for loop, and we know that through std is lower, we're going to increment the lowercase count. If it is uppercase, we're going to increment the uppercase count. This is how we can do this. And we are going to print that information when the loop here is done. Okay, we still have a few examples ahead. The current one is going to check if a character is a digit. If you want to do that, you can use this. And we have a character array here, and we're going to hunt for digits inside this message here. So we're going to do basically the same thing. We're going to set up a variable that is going to keep track of how many digits we have in this message. We are going to loop around using a range-based for loop. We're going to check if the current character is a digit, and we're going to increment our variable here if it happens to be the case. And at the end, we're going to say how many digits we found in our message here. It is this simple. The last example we're going to look at is to help us turn a character into lowercase or uppercase. And here is an example that is going to help us play with this. We're going to have a character array called home, the feeling of belonging, and we will set up a destination character array that we're going to store whatever we want to set up in. Here you see a loop that is going to turn our message here into uppercase. And you see, we're going to loop around by this amount, the size of original string, and we're going to be grabbing each character at each iteration and turning that to uppercase. This is what std to upper function does. The result of that is going to be stored in our destination string, and by the time we are done here, original string is going to be however it was, but uppercase string is going to be stored in our destination array, and if we print it out, we should see this thing printed in uppercase. We can basically do the same thing and turn the string into lowercase, and our destination string is going to be now lowercase, and you're going to see that this works out pretty well. Now that you have a basic understanding about how these things work, we're going to head over to Visual Studio Code and play with us. Okay, here we are in our working directory. The current project is character manipulation. We are going to grab our template files like we always do, and we're going to put this in place. And we're going to open this in Visual Studio Code pretty quick. And we are going to go down and put in our first example. This example is going to be using the std is alnum facility. And this is going to be checking if a character is alphanumeric. We're going to see what we get from this if we print this out. We're going to check if C, the character C, is alphanumeric. We're going to see what we get. And we're going to check if this character here, I don't know how to pronounce it, I'm sorry. We're going to check if it is alphanumeric. We're going to see that. And we're going to use this in a condition. We're going to check and see if our star character here is alphanumeric, and we're going to print that out. We're going to say it is alphanumeric or it is not. From the documentation, we know that this thing lives in the CC type library, so we may want to include that, but it is possible that it is coming from IOStream here. That's why we don't see Visual Studio Code complaining here. As an example, if we try and comment out this include here, you're going to see that this is not going to make sense anymore. Okay, so the include needed to use these guys here is coming from IOStream. Okay, so we're not going to include that here. We are going to open up a terminal and build this with GCC. And you're going to see that the build is good. If we go down and clear, let's clear properly and run Rooster, we're going to see that C is alphanumeric because we have a 1. The 1 can be treated like a true, and the character here is not alphanumeric because the result is 0. And you see that the star here is also not alphanumeric, and we know this through our test here. And you see that we can do things like this with this facility here. If you want to get true or false from this function, you can turn this into booleans using static casts, but we're not going to do that here. You already know that. We can comment this out for now and look at another facility from the CC type library. There are many of these. We're going to look at quite a few of them. We're going to comment this out and go down and put in our code here. And this is going to check if a character is alphabetic. So if it is an alphabet character, A from Z, lowercase and uppercase. C is alphabetic. The character here is not alphabetic, and 7 here is not alphabetic. So for the first one here, we're going to get something not equal to 0. We should get a 1. That's what they use in most cases. For this, we're going to get a 0, the second one, and for the third one, we're going to also get a 0. This is what we expect. We are going to build with GCC, of course, and we are going to clear and run Rooster, and we're going to get that C is alphabetic, this guy is not alphabetic, and 7 is not alphabetic. If we change this C to E, for example, lowercase, and build again, you're going to see that the results are going to be what we expect. E is alphabetic. Let's clear and run Rooster. This is going to be exactly what we expect, but you see that it is not a 1, and this is not guaranteed to always give you a 1. It is guaranteed to give you something different from 0 if the character is alphabetic, and 0 if not. And we can use this guy here in a test. For example, we can say if STD is alpha, and if we build, the build is going to be good, and we're going to clear and run Rooster, and you see E is alphabetic. I should put a space here. I do encourage you to change these characters up and see what you get here, and see how you can use these things in tests. That's the best way to learn. Okay, before we continue, I do encourage you to try and run these methods through different compilers. For example, here we also have an MSVC compiler from Microsoft setup, so we can use that and try to build this thing here. But before we do that, let's bring up our pen here and remove rooster.exe here because we don't want to override it. We're going to select it and do delete. And I am going to remove this and move that to the recycle bin. And I am going to clear whatever I have here on the terminal. And I am going to go there. I'm going to choose run task. And I am going to choose build with MSVC here. I am going to use that. It is going to build my thing. You see the output here. And we have rooster.exe here. And it should say that the build is good in a minute. Build finished successfully. Microsoft is going to give us a lot of output here, but no problem, the build is good. If we go in, we can actually check and see what we have in our folder here. You're going to see that we have these files. One of them is rooster.exe. If we run it, we are going to get the output that we expect. And you see that it is exactly the same thing we got with GCC. I am telling you to try and use different compilers because some compilers are going to flag some of the facilities from CC type or those that start with C as unsafe because there are some things that can really throw you off about them, and we're going to learn about them in this chapter as we move forward. Just know that it is a good idea to try these things on different compilers and see the errors you get and make yourself familiar with those things. For now, we're going to move on and we are going to keep using GCC because that's my favorite compiler. You can use whatever compiler you want. The next example is going to check if a character is blank. Let's close this thing and clear and give ourselves some breathing room. We're going to bring this down a little bit and we're going to check if a character is blank. The facility for that is std is blank. And if it's a blank character, we're going to get something different than 0, and we can use that in a test like this. And if it's not a blank, we're going to get something equal to 0, and this test here is going to fail. So what this example here is going to do, it's going to count how many blank characters we have in this message here. And we're going to print the count of that on the console using this line here. So let's go through this loop and see what it does. The first thing we do is initialize blank count to 0, and we are using an integer, and because this is a count, I think blank count is of wrong type because int can be negative. So to really be safe in our program here, we should make this unsigned or even use size t. This is better. Okay, so let's use size t because this is a size, and size t is a good type to keep track of sizes in your C++ programs. So make sure you use size t here. And what we're going to do is go in the loop. At each iteration, we're going to check if each character at each iteration is a blank. If it is, we're going to fall in here and say that we found a blank character at this index in our array here, and we're going to increment our blank count. And by the time this loop is done, we're going to have the blank count stored in this blank count variable, and we're going to print that out. It is this simple. Now we can build with GCC. Let's do that. We're going to build with our GCC compiler, and the build is going to be good. You can clear and run Rooster, and you're going to see that it's going to say we found a blank character at index 5, 12, 20, 24, 31, 35, 39, and 42. And in total, we have found 9 blank characters. Do we have that many? Let's count. So one blank character. We have 2 here. We have 3. We have 4. We have 5 here. We have 6, 7, 8, and 9. If you count, you're going to find that we have them. And the first one is at index 5. So index 0 is H. 1, 2, 3, 4. The first one is at index 5, and this is doing exactly what we want. We can go down and check if a character is uppercase or lowercase. We can do that through an example like this. And the facility is going to be std lower and std is upper. We have a message here. We're going to loop around using a range-based for loop, and we're going to check if each character is either lowercase or uppercase. And if the test is good, we're going to jump in the loop and we're going to increment lowercase count, which are a few variables to keep track of how many uppercase and lowercase characters we have in here. And again, these variables are going to store counts, so it is better to use size t or some unsigned integer type. But now we're going to use size t because it is good. So we're going to keep this stored in here and we're going to build this and see what we get. Before we run, we want to clear, and we are going to build with GCC. The build is going to be good. We're going to clear and run Rooster, and you see that the original string is this guy here. What we're going to do, we're going to print whatever character we are at. We're going to put a space in front of that, and we're going to see increment. This is the output. Why do we have this message here? Because we are printing out each character, and we are not printing the uppercase ones. We are printing lowercase ones. That's why you see this guy here. This is really interesting. You can keep this in if you want. I am going to keep this in. The important message is that we found lowercase characters and uppercase characters, and we have 5 uppercase characters. If we go in and count, we're going to find that we have T here, 1, 2, and 3, and 4, and 5 uppercase characters. And if you count the lowercase characters one by one, I am sure that you're going to get a 47 like we did here. We're going to comment this out because this was just an example. I am leaving this in here so that you can use this as a reference if you want. We can also check if a character is a digit, and we're going to use std is digit to check that. The return type is going to be different from 0. If the test succeeds, if it fails, we're going to get a 0, and we can use that like this. So we have a message here stored in the character array called statement, and we're going to loop around checking if each character we are at is actually a digit or not. If it's a digit, we're going to say found a digit. We're going to say whatever digit we found, and we're going to increment the digit count, and we're going to store that information in this digit count variable here. We don't want to make it an int, so we're going to make it a size t, and we're going to build and run this program and see how many digits we found. You know, it is this number here. I'm not going to say it. We're going to let our program figure this out. So rooster, and we're going to find 2, 2, and 1. So we found 3 digits, and it is exactly what we expect here. We're going to comment this out and show you another example. And in the last example, we're going to be showing you that you can change the case of a character. If it's lowercase, make it uppercase. If it's uppercase, make it lowercase. And you can do things like that. We have a message here stored in our character array called original str. We set up another array which is going to store our message that is transformed. And we're going to loop around, turning everything we come across uppercase. The way we do that, we're going to say std to upper. And we're going to pass in the character that we want to turn to uppercase. If we do that, we're going to get an uppercase character out of that. And we're going to store that in our destination array at this index here. It is this simple. After that, we're going to print the original string and the uppercase string. We should get that printed out because it is stored in destination string here. And we're going to do the reverse and turn that back into lowercase. We're going to grab the original string, loop over it, and at each iteration, we're going to get whatever we have and turn that to uppercase, to lowercase, I should say, and the result of that is going to be stored back in our destination string. So we're going to overwrite whatever we have in our destination string here. And after that, we're going to print the lowercase string, and we should get that printed out. This is how the example works. And if you have any problem understanding this, I am always around. Please do ask. I will do the best I can to help you out. For now, we are going to build this with GCC. The build is going to be good. We're going to clear, and we're going to run rooster, and we're going to see that the message is here. It is turned uppercase, it is turned lowercase, and this is how you can do these things here. So we have looked at a few of these facilities from CC type. I don't really want to look at all of them because that would be really boring. I hope you have an idea about how they work, and if you want to look at all of them, all you have to do is come to the documentation here, choose one, open it up and look at the documentation, and in most cases they are going to have examples down here that you can look at and play with. For now, we are going to stop here in this lecture. This is really all we set out to do, to play with many of these facilities from the CC type library. In the next lecture, we're going to look at how we can manipulate C strings. And by that, we mean concatenating them or putting them together, copying them out, and doing all kinds of crazy things. Go ahead and finish up here and meet me there.